If you were to stand on the frozen, cratered surface of Mimas, Saturn's innermost major moon, and look up into the silent sky, you would see a vista of almost divine beauty, a colossal golden sphere, belted by rings of shimmering ice that stretch for hundreds of thousands of kilometers, spinning in perfect, silent harmony. It is the archetype of cosmic order, the jewel of our solar system. But beauty, in the cold, mechanical reality of the cosmos, is often a mask, worn by chaos. Beneath that serene golden haze lies a planetary dynamo that should not exist. A force field so perfectly aligned, so strangely symmetrical, that it violates the fundamental laws of astrophysics. According to every mathematical model we have constructed to explain how planets generate magnetic fields, Saturn's shield should have collapsed into nothingness billions of years ago. Yet, it persists. And as the Cassini spacecraft dove through the gap between the rings and the atmosphere during its final suicidal grand finale orbits, it detected something even more disturbing. A magnetic field that is not just symmetrical, but one that refuses to reveal its internal tilt. A field that behaves as if it is being generated not by the chaotic churning of liquid metals, but by something engineered, something hidden deep within the high-pressure metallic ocean of the planet's core. We are about to peel back the layers of this gas giant. We are about to descend into a realm of pressure that turns gas into metal, and confront a reality that suggests our understanding of the universe's basic dynamos has a catastrophic blind spot. To understand why Saturn's magnetic field is a scientific heresy, we must first understand how a planet is supposed to generate a magnetic field. We live on a world protected by an invisible bubble, the magnetosphere. It deflects the lethal stream of high-energy particles from the sun, the solar wind, preventing our atmosphere from being stripped away into the void. Without this shield, Earth would be as barren and dead as Mars. Our shield is generated deep beneath our feet, in the outer core. Here, a turbulent sea of liquid iron and nickel, heated by the decay of radioactive elements and the crystallization of the inner core, is constantly in motion. As the hot, liquid metal rises, cools, and sinks, it creates convection currents. But liquid motion alone is not enough. Earth is spinning. Because of this rotation, a secondary force comes into play, the Coriolis effect. This twisting motion aligns the convective columns along the Earth's axis of rotation. The movement of this electrically conductive liquid through these twisted paths generates electric currents, and these currents, in turn, generate our magnetic field. This is the self-exciting dynamo theory. It is the foundation upon which all planetary magnetism rests. But there is a catch, a crucial mathematical rule. In 1934, a physicist named Thomas George Cowling formulated a theorem that would define astrophysics for a century. Cowling's Theorem. In simple terms, Cowling proved that a magnetic field cannot be maintained by a fluid flow that is perfectly symmetric about an axis. If the fluid motion and the resulting magnetic field are completely axis-symmetric, if they look identical no matter how you rotate them around the spin axis, the magnetic field will decay. The system cannot sustain the electric currents necessary to keep the dynamo alive. To work, a planetary dynamo requires asymmetry. It requires a tilt. On Earth, this tilt is obvious. Our magnetic pole is tilted by about 11 degrees relative to our rotational axis. On Jupiter, the tilt is about 10 degrees. Even on Uranus and Neptune, the fields are wildly off-center and tilted by up to 59 degrees. This tilt ensures the fluid flow is complex, chaotic, and non-axis symmetric. It keeps the dynamo running. For decades, planetary scientists assumed Saturn was no different. They assumed that underneath its thick, uniform layers of helium and hydrogen, Saturn possessed a tilted magnetic field. Perhaps just hidden from our telescopes by the planet's atmospheric currents. Then, we sent Cassini. As we descend into Saturn, the scale of normalcy completely disintegrates. Saturn is not a solid world. It is a gargantuan ball of hydrogen and helium, 95 times the mass of Earth. As you drop deeper into its atmosphere, the pressure increases to levels that defy human comprehension. At a depth of about 20,000 kilometers, the pressure exceeds 1 million atmospheres. The temperature climbs past 10,000 Kelvin. Under these extreme conditions, hydrogen ceases to behave like a gas. The molecules are crushed so closely together that their electron shells overlap. The electrons become delocalized, free to move from atom to atom. Hydrogen becomes a liquid metal, metallic hydrogen. This metallic ocean is highly conductive. It is here, in this crushing, hot, liquid metal interior, that Saturn's dynamos are born. Scientists expected that the turbulent convective flows within this metallic hydrogen ocean would generate a magnetic field with a clear, measurable tilt. They expected to see the magnetic poles wandering, just as they do on Earth. But when the Cassini spacecraft arrived in orbit around Saturn in 2004, its magnetometers detected something that shocked the team. The magnetic field of Saturn was aligned, almost perfectly. Initial measurements suggested the tilt was less than 1 degree. As the years went on and the data became more refined, the angle shrunk further. 0.5 degrees, 0.1 degrees. In 2017, during the grand finale, Cassini flew closer to Saturn than any spacecraft before, dipping inside the inner edge of the rings, just above the cloud tops. The primary goal of these daring maneuvers was to measure the magnetic field with unprecedented precision, to finally detect the tiny tilt that must exist to satisfy Cowling's theorem. The result? The tilt of Saturn's magnetic field is less than 0.01 degrees. It is, for all practical purposes, perfectly aligned with the planet's spin axis. This is not just an anomaly. It is a crisis in planetary physics. If the tilt is truly zero, then Saturn's dynamo is axis-symmetric. And if it is axis-symmetric, then according to Cowling's theorem, it is mathematically impossible for Saturn to have a magnetic field at all. The field should have decayed and vanished billions of years ago. Yet, there it is, deflecting the solar wind, trapping radiation, a shield of immense power wrapping around a planet that has no right to possess one. How is this possible? The leading scientific explanation is a concept known as magnetic shielding. Some scientists propose that deep within Saturn, above the metallic hydrogen layer, helium is condensing out of the hydrogen mix, forming droplets that rain downward toward the core. This helium rain zone is thought to be non-convective and electrically conductive. As the outer layers of the planet rotate at different speeds, a process called differential rotation, it might drag the magnetic field lines, smoothing them out and hiding the true tilted dynamo beneath a shroud of perfect symmetry. But this is a theory built on assumptions we cannot verify. We cannot see through the helium rain. we cannot probe the metallic hydrogen ocean, and the models required to make this helium shielding work are highly tuned, almost too tuned. They require specific, precise boundaries of temperature and composition that seem highly improbable in a natural, chaotic planetary system. If the helium rain model is wrong, then we are left with a terrifying alternative: our fundamental equations of magnetohydrodynamics. The math we use to explain the magnetic fields of stars, planets, and galaxies is missing a core component. If our understanding of magnetic dynamos is fundamentally flawed at Saturn, the implications do not remain 1.4 billion kilometers away. They cascade back to Earth. Earth's magnetic field is our shield. It is the only thing that prevents the solar wind from turning our blue world into a sterilized desert like Mars. We rely on the dynamo theory to understand how our core behaves, how the magnetic field changes, and when the next magnetic pole reversal might occur. A pole reversal is a chaotic event. During the transition, which can take thousands of years, Earth's magnetic field weakens dramatically, exposing the surface to dangerous levels of cosmic radiation, disrupting power grids, and destroying satellite infrastructure. Our models tell us that Earth's field is stable because of its non-axis symmetric, tilted nature. But if a planet like Saturn can generate and maintain a powerful, perfectly symmetrical magnetic field through a mechanism we do not understand, it means we do not truly understand the stability of our own shield. It means there are physical processes operating inside planetary cores that we are completely blind to. Processes that could, in theory, trigger changes in Earth's field that our models cannot predict. But there is another, even more unsettling angle to this mystery. Saturn's magnetic field behaves like an engine that has been engineered to run in perfect symmetry. In the search for techno-signatures, evidence of advanced alien civilizations, scientists look for structures that defy natural physics. A Dyson sphere? A star with unnatural chemical abundances? Could Saturn itself be a signature? Not the planet itself, but perhaps something within it. A massive artificial core, an object left behind in the deep, crushing metallic sea, generating a stabilized magnetic field to preserve the planet's structure, or perhaps to act as a cosmic beacon. It is a concept that sounds like science fiction. But when the science we have fails to explain the data, the boundary between the natural and the artificial begins to blur. Why is Saturn's magnetic field perfectly aligned? What is happening in that dark, high-pressure ocean of metallic hydrogen that we cannot see? We left Cassini to burn in the Saturnian atmosphere in September 2017. It became part of the very planet it was trying to understand. Its final signals were cut off as it tumbled into the clouds, leaving us with a wealth of data and a mystery that challenges the very foundation of planetary physics. Saturn spins in the darkness, silent, golden, and fundamentally broken.